Okay, so for this lesson, we're going to learn about related rates, and there's basically 4 steps. So the first thing we're going to do is read the problem, of course, identify your knowns and your unknowns. Okay, so then you see this FWG. F stands for find. We got to figure out, okay, what are they asking us to find? When, the W stands for when, this is like what we know at that moment in time. Okay, the G stands for given. These are usually rates that are given that are true throughout the problem. 2 says find a relating equation. So this E right here, E stands for equation. And what does that spell? FWG, right? FWGE. This is what we're going to always identify at the beginning. Then we're going to differentiate implicitly with respect to time. So we're going to do d over dt, both sides of the equation. And from there, it's basically plug and chug. Okay, so we have this first problem. Air is being pumped into a spherical balloon. So we have a sphere at a rate. I see rate. You need to be thinking that's a derivative word of 4 pi cubic feet per minute. Determine, that to me sounds a lot like find. How the radius is changing. Again, there's a derivative word. When, okay, that's part of my FWG. The radius is 18 inches, and then they give us an equation. So let's write all this out. So first we're going to find how the radius is changing. So we're not finding r, we're finding the derivative of r with respect to t. W, when? When the radius is 18 inches. Okay, that's always the easiest part to find. G is anything else that's given in the problem. Okay, so right here it would be this rate. So it doesn't say volume, but your hint that we're talking about volume is right here with this cubic. The other thing is, we're talking about air inside a balloon. That's going to be volume. So what they give us is dV over dt. The rate at which the volume is changing is 4 pi cubic feet per minute. And then they give us the equation, volume of a sphere, to be 4/3 pi r cubed. Okay, before we move on, I have an issue with units. I have feet and I have inches. So what we're going to have to do is change that 18 inches to 1.5 feet. Okay, so we're going to write our equation again. So after we do FWG, we write the equation. Okay, and then we are going to take the derivative with respect to time of both sides. So the derivative of v, that's going to be 1, and then dv over dt, because if I'm taking the derivative of a v with respect to t, I gotta have this kind of like mini chain rule. You don't have to have the 1, and in fact, I'm going to go ahead and erase the 1 times. Okay, over here, 3 gets multiplied to the 4/3. Okay, that ends up just being 4 pi r, subtract 1 from the power, and again, dr over dt, because you took the derivative of an r, which is a function of time. So we're going to say anytime we take the derivative of anything other than t, we're going to do d, that letter, over dt. Okay, the next part is, we did the hard part. The next part's the easy part, okay? Remember, we're trying to find dr over dt. This is what we're trying to find. So everything else, we should be able to plug something in. So dv over dt, that's right here. That's 4 pi. All right, 4 pi r, okay, that's 1.5 squared dr over dt. Now I just got to find dr over dt. So you could multiply that and then divide. You can do it all in one step. You can use your calculator here. So however you get the next part, okay, you could do this by hand. It's really not that bad. But you end up getting dr over dt equals 4/9. And you got to think about your units. R is radius. Our units for radius were feet. Our units for time were minutes. So feet per minute. That's important. If you want to do this as a decimal, you have to go out to 3 decimal places. Okay, so then we have this next problem, problem 2. It says the side of a square is increasing. So we couldn't draw a picture of a sphere, but sometimes drawing a picture here helps. So we have the side of a square. We'll call the side x. is increasing. So we have a side that's increasing at a rate. Those are derivative words. 0.4 centimeters per second. When the side is 5 centimeters in length. What to me, they're basically saying find the rate of change. Again, those are derivative words. The area of the square. So what we're trying to find here is dA over dt, the rate at which the area is changing. Okay, when, okay, they said the side we called x. You could use any letter you wanted here, by the way. Okay, given, okay, the side is increasing. That's a rate, so I'm going to do d, in this case dx over dt equals 0.4 centimeters per second. My equation is going to be relating x to a. Okay, so my relating equation, relating a to x, is going to be the area of that squared equals x squared. So I'm going to rewrite this equation, a equals x squared. I'm going to take the derivative with respect to t, so that gives me dA over dt equals derivative of x squared is 2x, dx over dt. Remember, we're deriving with respect to t, so we always have these little statements after we take a derivative of a variable. So again, this is the easy part. Remember, we're trying to find dA over dt. We did all the hard work. Now we just got to plug everything else in. So dA over dt, that's what we're looking for. So x, I should have, and I do, it's 5. dx over dt, that's 0.4. So this ends up being 4. And again, you got to think about, okay, dA, area, that's going to be square centimeters, or centimeters squared. T time, they told us that was seconds. Okay? So looking at the next page, oops, I skipped a page there, a couple pages. We have a new problem. And so we're just going to go through. If you want to pause, if you're just watching this video, maybe pause and try this one on your own. Circumference, increasing rate, those are derivative. Also derivative because of per, my units there. When the circumference, so there's my when the circumference is 10 pi inches, how fast is the area increasing? Those are more derivative words. So I'm trying to find how fast the area is increasing. When the circumference is 10 pi inches, given, that goes back to the first, that's when the circumference is increasing, so dc over dt equals 2 pi over 5 inches per minute. My equation then, well, I've got area of a circle going on with circumference of a circle. So we're going to write both down, and we're probably going to use both, but I'll explain to you how I think about this. Okay, now look at what you're trying to find, dA over dt. That means you're going to have to take derivative of that formula. So I'm going to start there. A equals pi r squared. If I take derivative of both sides, I get dA over dt equals 2 pi r dr over dt. Interesting that when you do basically derivative of area equals circumference, that happens. So, you know, I'm looking for dA over dt. So what you're hoping is that you know all of this other stuff, like how it worked out in the other problems. Well, here's the deal. I don't know r. R wasn't given. And I don't know dr. Dr wasn't given. So I'm going to have to use the information that I was given, this other stuff, and go off to the side and figure out, okay, what is r and what is dr over dt. R is the easier one to find. If you know that the circumference is 10 pi, and you know that the equation is 2 pi r, that means that r must equal 5. Okay, so I'm going to go ahead and put a 5 there. Okay, the other one is a little bit harder. Let me rewrite the equation. C equals 2 pi r. Now, if I'm supposed to be using dc over dt, that means I'm going to end up having to take derivative of this as well. Sometimes you have to take two derivatives, two different equations. It's rare, but it happens. So you get 2 pi dr over dt. This is good because I know what dc over dt is. I know that it's 2 pi over 5. And so I can figure out with some algebra that dr over dt is equal to 1/5. Okay, just use your calculator to solve that equation and divide and multiply and all that good stuff. So that goes right there. And this is kind of nice because the 5 and 1/5 cancel. You're left with just 2 pi. Again, your units, area units are inches squared. Time in this problem is in minutes. So 2 pi square inches per minute. Okay, I'm going to just go straight to 5, and then this is going to be the end of this video. So again, we have a spherical balloon. It's being filled with water so that the volume is increasing at a rate. These are all derivative words. How fast, increasing, those are derivative words. When the diameter, there's my win, is 50 centimeters. So again, if you're just watching this for the first time, I would pause and see if you can fill this out and then watch me go through it. So what we're trying to find, how fast is the radius of the balloon changing? That's dr over dt. Okay, when the diameter is 50 centimeters, I'm going to stop right here and say, diameter, I don't really like you that much. I like radius a lot more useful, 25 centimeters. Okay, given, okay, here they actually use the word volume, which is helpful. dV over dt equals 100 cubic centimeters per second. And then if you forgot the equation, you could just turn back a page. This is an equation you should kind of start to know. So here's my relating equation, volume of a sphere. So I rewrite it. And then what I'm going to do is I'm going to take derivative with respect to t of both sides. I'm left with dV over dt equals 4 pi r squared dr over dt. Side note, 4 pi r squared is the surface area of a sphere. So if that comes up, that's the surface area of a sphere is 4 pi r squared. These are formulas that come up in these problems. It's good for you to know them. All right, now back to our problem. I'm trying to find dr over dt. So I got to plug in everything else. So I got 100 equals 4 pi, r is 25. So we were glad that we changed from diameter to radius. And then divide, right? You can multiply and then divide, or you can just do this all in one step. Again, that's a preference, and you have a calculator to do the math, although most of these can be solved by hand. Like for instance, in this case, the 4 and one of the 25s would cancel with the 100. All right, and you're left with 1 over 25 pi. If you're not good with number sense, though, just use your calculator. Remember, if you get a decimal, you got to round to 3 decimal places. No less than that. You can go further out, but not any less. R, radius, that's centimeters per second. Make sure you got your units right.